Great. So I'm Zach. I'm with NYC Mesh, and we're New York City's community network, internet for everybody. Oops. Great. So just a little bit about myself. I'm a computer engineer. Hardware, chips, firmware, that kind of stuff. And I've been here at NYNOG with the rest of you guys. You probably have seen me around the different events that we've had in person, but I've been doing NYNOG since almost the beginning. I think I missed a couple, but you might have seen me around. And my day job is HPC, supercomputers, and things like that. It's not networking. But I do networking as a hobby since a while now, maybe the last 15 years. Especially prefer BGP, benchmarking different equipment on my own, which is kind of fun. Collecting gear, running VPNs around the world, and having some colo gear. So that's just for fun. And so out of that fun came my interest in NYC Mesh, which I've been doing with for about 5 years now. And now I'm board member of the organization. And I pretty much run the supernodes and help in a couple of other areas. So just a little background in case you've seen me, but you don't really know who I am. But NYC Mesh, what is it? Who uses it? And then we'll talk a little bit about technical information about the mesh. So what is it? We are a community network, which is a mesh network, we sometimes call it. We're what we call a commons, and we're also a nonprofit. And our goals are to connect the unconnected, provide some choice for people, and educate and grow people, and of course have fun. So as a community network, you might be familiar, might not be familiar, but the community network concept started it started in the early 2000s, kind of mostly in Europe and the UK type area. One of the first ones was in the UK, and one of the other really early ones was in Greece. And they kind of spread around that area. Really, they're just neighborhood projects or they're regional projects, and they're operated by the volunteer members themselves. They typically take a more grassroots approach, and mainly this is because they would typically focus on a more rural area and providing access to areas where there really wasn't DSL. It didn't make sense for the phone company to come out there and provide access to them. This is barely before the cable internet days, certainly before the fiber to the home days. And it was just provide net access to the public. And they typically have a little bit more open policy. They're not really restricting because they're kind of, it's run by the community rather than by an organization. Here are some community network images on the left. This is one of the first community networks over in Greece. It's really, you can see very early equipment. You can look at the age of the laptop. This is some time ago. And on the right, you can see a more recent network that's happening in Nepal. It's quite rural, and you can see that it's really just whatever they can get and put it together to build this network. So community networks often use their own dynamic routing protocol, kind of in a more flexible configuration where they'll quickly switch from one area to the other area. They usually use more cheap home routers and plastic boxes and things like this. Whatever you can do, the goal is to build something out of nothing. But we kind of adapted this to the more modern, current, large city times. We're 20 years later. Things are off the shelf very easily. You can get older routers all over the place. So, we're a more modern version of that at this point. Great. And as a commons, I don't want to get into any kind of political or theoretical idea about what this word means or anything like that. But basically, it means that the resources that we're running overall are owned by the whole community. They affect the whole community. They're for everybody. They're owned in common. They're not owned privately. And it's for the collective benefit of all the people. And so we don't own the network. It's just something that everybody owns together, and everyone can use it as long as you don't mess it up for everybody else. So that's kind of the idea. And along with that comes the concept of no commercial use. And what we really mean by that is, you can't use this as your means of internet if you're an internet company. You can't like run websites and charge a profit or that kind of thing. It's not for companies who are selling internet or something like that. If you run a coffee shop, you can use this internet. It's fine. And we're a nonprofit, so we're a 501c3 in New York State. We're 100% volunteer run, 100% donation based. We have a few grants from ISOC NY, Mozilla, and Andbox, a local company here. And we have donors. These donors are people that are on this call right now, and we thank them very much. Packet Pilot, Ubiquity, WebAir, Init7, DKIX, and just a whole bunch of people who have done it themselves, cut a check to make it happen. So very good. And overall, we are pay what you want. We recommend at $20 a month for somebody if they're using it and they enjoy using it and they find it useful. But some pay more, some pay less. You don't have to pay anything. We want you to donate, and we trust that the members are going to cover the costs of the network overall. But you do have to pay for some equipment. It's a couple $100s to put an antenna on a rooftop, and you can do it yourself, or you can get some volunteers. So it's all very flexible things. Again, kind of running with the idea that this belongs to everybody. So all the money that we just mentioned, the formatting went a little weird here, but all the money that we just mentioned goes to supporting the community infrastructure. So for supernodes, which I'll talk about in a second, it means leases, fiber, upgrades of servers and routers and things like that. We actually lease some space in data centers in order to connect to the internet and put antennas on the rooftop, and that's paid for by the donations. And for hubs, it means if we need to put a sector antenna there, we put a sector antenna there, and that comes from the community money. Same for subsidized installations. If someone can't afford an installation, we help it out, right? And training, events, pizza, materials, things like this to get people educated and help them understand what's going on. And connected and connected, providing choice. Many New Yorkers just don't have a home connection. And it might be a little surprising to hear, maybe for some people, maybe not, but about 26% of New York City doesn't have a home connection to the internet, which is about 2 million people, right? And some of it's because of bad wiring. Some of it's because it might not be worth it for the company to deploy fiber into the building because a certain number of residents aren't ready to sign a 2-year deal or something, or they make it just as good as they can get. I personally have even had this experience where, when I had a real job and I had a real apartment, the internet I had was down more than it was up. And it wasn't because of the area I lived in, that's just the fact. And in another place, I even had to, borrow the internet from the coffee shop down the street because they're just, the installation timeline was 6 months. So it's just a fact of living in New York City sometimes. And education and growth, we have all kinds of things that people do in the mesh. There's drilling, crimping, there's climbing buildings, aligning antennas, working on routing infrastructure, websites, databases. We even wrote a custom Docker plugin to achieve what we wanted with those. And we share this by either having person-to-person meetings, small group trainings. Let me show you how it works. Let me show you how it happens. Or some bigger seminars. We also have a documentation website, which there's a link later in this presentation, that a lot of other groups have kind of hooked onto, and they use that as educational material for their own networks. So it's kind of nice, and our goal is to launch one of our goals, many goals, is to launch community networks in other locations. So we're helping with Baltimore, we're helping with some places in New Jersey, we did a couple in upstate New York. So we're trying to help people understand that they can do it themselves. And many of our volunteers even didn't have a networking background. We had some amazing transformations. We have one guy who's a stay-at-home dad, and he turned into a network engineer. So, completely from nothing all the way up to knowing quite a bit. We have an actor and a playwright who now climbs buildings and does concrete work. So these are skills that people didn't know that they had, but they found an interest and they came to it. We have one person as a business finance manager, and now he's a BGP guru. So, and he runs his own ASN and has his own public IPs and everything. So it's pretty nice that people can come in, and really the platform that we're building is for people to come in, try something, use it to educate yourself and have the right tools at home to be able to grow. Right. So who uses it? All kinds of people. We don't exactly know, and that's part of the fun. We estimate maybe 500 to 1,000 people use NYC Mesh on a daily basis. In a minute, I'll show you how many nodes we have on the network, and you can see that this number does make sense. And there's all kinds of different places: coffee shops, art galleries. We even have a Buddhist monk who uses it. We have college students who are doing online classes, and they've recently signed up to use it. We're in NYCHA buildings. We even have a guy who owns a bunch of real estate, a bunch of buildings in New York. He uses it as his home internet, and even construction sites somewhere where they're not an internet company, but they need to check their email or something, and there's no wires because they didn't build it yet. So it works out that we're a good solution for that as well. And again, fun. If you can know the entire path that your packet takes to get to the internet, and you can even have seen the antennas and the routers that it goes through. And so this is, if you're the kind of person that wants to know that, you can learn that from here. And if you want to play with routing, or if you want a BGP ASN in your home, you can do that with NYC Mesh. So I don't think you can do that from any other commercial ISP that has home internet at the moment. So today we have 508 access nodes. These are just nodes on people's rooftops, just any kind of rooftop, 3-floor building, any kind of thing. We have 54 hubs, and this is a designation where the antenna, the node has maybe 5 or 7 different antennas pointing in different directions, giving some coverage. And the blue shaded areas in the map are the result of these hubs providing coverage to areas. And we have 2 supernodes, which are these buildings that it's a data center, it has a rack and fiber, and we run the wires up to the rooftop. And you can even see up in the corner here, here's Dave Temkin's node. So we have people who are part of a NYNOG here who are in the mesh participating, and we really think that's great. I threw this graph in real quick at the end. Our all-time growth, from nothing, you can forget the percentage right here, it's kind of silly, but you can see from 2015 to 2020, we've been on a pretty steep curve of growth, and you get a little wiggle right here for COVID, but this is actually installations that occur. So this is not just requests, but actually antennas that got turned on that year. And in the 1 year over here, we've grown 71% this year so far. So we've gone from 300 all the way up into the 500s, and it's really a very high growth situation. So now the technical part, which is what I'm sure you're all waiting for, enough of the organizational information. And just as a fun warning, our network might seem a bit odd because we have different goals than maybe a carrier network. We're a bit bigger than some networks with being in about 500 buildings, but we might be doing some crazy things where we don't manage it exactly the same way, or we might do something that looks a little bit off in terms of routing, but we do that because we're trying to provide open access, easy installation, and we're not a locked down network where you have to verify all the routes. So it's a little bit different, and so you have to bend your mind a little bit on it. So firstly, in IPv4, we're using all private 10 dot addresses in our network. We're fully routed, so there's no layer 2 across the network. There's no VLANs and so on. 1 subnet per building, it's auto-generated. And the NAT is at the edge, it's on the supernodes. And you float around a network in private IPs. When you hit an edge, because you went through a default route, you go to a supernode and you do NAT through a small pool of public addresses and you go out. You can also get a public IP in the mesh, and we just route it in the IGP, or you can even bring your own addresses and put them into the mesh. And there's a little bit of work to do that, but it's not very hard. And so it's very open for people who are playing and doing DIY. In IPv6, we now have a /32 allocation, so we're just like any other LIR. Rollouts are starting this year. We're a little behind though. We're a little behind, and part of the reason is without an allocation, without getting this /32, you have to choose between one of these things. And this might not be something that carriers think about too much, but if you don't have your own public IP addresses for IPv6, then you're really stuck in a small area of problems. So you either have to use ULA with NPT v6, network prefix translation, but if you do this, you have all kinds of checksum problems, you have application issues, you have multipath issues, and it really is quite a challenge to do NPT v6 on our scale. If you just had a small office building, it wouldn't be too hard, but for what we're doing is kind of a challenge. We can also do 464 XLAT, but we would need to deploy specific CPEs at every apartment in the whole network, and that would be a huge pain, and it's a non-starter for us. And we can also use someone else's allocation and renumber, But having to go to 500 different locations and renumber it, even virtually, is going to be a huge pain. So we're deep into IPv6 now. We're trying to be at least, and the main holdup is stateful firewalling at the edge with asymmetric routing. So we just want to make sure that we do it right, and we want to provide the most options for people. So IPv6, a fun topic. I'd be happy to argue it out with you guys in the breakout room later. And so for routing, we use OSPF. We use the boring old IPv4 OSPF, v2, and we have one area. We have the backbone area 0. And yes, that means we have 500 or more routers in the backbone area, which some of you are probably wiggling in your chair going, oh man, that's a bad idea. Like, that's crazy, right? But yes, it is a little bit crazy, but we think that it's okay to go at that scale, because we know some larger networks have done that. We know a few other mesh networks that have gone to 1,000 or more in the OSPF table. And we know that there's ways to implement some other network types, and we could split a few areas and a few large areas into smaller stubs and so on. So we're not too worried about it, but actually this has been a really great choice for us. And we do one subnet for every node. It now says an external type 1. So we have 2 routes. Actually, I'll tell you about the next thing here. We use a PTMP network. So if you're not familiar with PTMP, it's very similar to point-to-point in that it uses just /32s to negotiate with each other. And you only have, there's no designated router or backup designated router. But the difference is that it uses multicast for neighbor discovery. And this is an important thing for us, because most of the other custom mesh routing protocols do an auto discover, but there's very few production enterprise ones that do an auto discover. And so we found this little edge in the corner of OSPF that lets us do this the right way. And so every router announces its own /32 IPv4 for the interface subnet, not the larger subnet that it's part of. So we have basically 2 routes in the whole routing table for every node. So why OSPF instead of these custom ones? Some of the custom ones may claim faster failover or better alignment with the goals of the network, but we wanted to settle on a standard, an open standard with an RFC that is implemented in hardware that everybody has. We needed neighbor discovery, so that ruled out things like BGP, unless you use special variants of it and chop it up a little bit. But we wanted something that we can implement on any brand of hardware, even Cisco routers, cheap routers, expensive routers, all kinds of things. And so we feel that this actually makes us more open than using some of the custom protocols that are more open source. Because OSPF is a standard, it's already open. So we wanted to go this direction, and it's been a pretty successful thing for us. And another oddity that we've done with OSPF here is we implemented this thing we call a peering network, which may sound familiar for like an exchange or something. But what we're doing is we designated one subnet, 1069/16, on every router. We put it in a local bridge, or a VLAN or a switch, whatever you'd like to call it. And this route does not show up in the routing table at all. And what we do is on that bridge, we turn on client isolation on all ports. So anyone plugged into that switch can only see the router that hosts the switch or the bridge, and not any other clients. And there's no layer 2 forwarding. We disable forwarding. There's no spanning tree. And so what you get is you get routers that plug into each other that can only see each other and nobody else on the switch. And so it's a really fast, cheap, easy way to do PTMP, creating basically a non-broadcast domain, but using broadcasts to discover each other. And so for example, in the diagram on the right here, we have 3 nodes, 5, 9, and 11, and both 5 and 11 are plugged into 9, but they can't see each other. And so this creates a network that's just a straight line, and it only has 5 routes in the routing table. And everyone has to go through router 9 in order to get to the other side, even if they're plugged into the same switch on router 9. So it's a little bit of an interesting oddity, and we've arrived at this by trying unnumbered, we've tried unnumbered interfaces. We've been trying 169.254. We tried putting a subnet in a table and allocating subnets to every router, and it's a huge pain. And this has eventually come to be something that's really worked wonders for us. And so what the effect is, you can just plug any two nodes together and they will instantly find each other, set up and route. And so it's great for both point-to-point connections and sector antenna installations. And this is what provides open access. Anyone can flash the firmware, take the router outside and plug it into some other router, and you will have a node on our network. For information in terms of OSPF, the radix that we're seeing in terms of neighbors, at our SuperNode 1, we see that sorry about the formatting here, but we see 21 neighbors on our OSPF neighbors table, 17 at SuperNode 3, and even down to this Saratoga installation in Brooklyn, we have 52 OSPF neighbors on that one router. So the network is very heavily using OSPF in this case. Well, this is very unfortunate about the layout. I'm sorry about this, but our design is using a couple different types of nodes. The super nodes are what we designate as our stable nodes. They're in a data center. They have fiber. It has a real lease. It has UPS power, and we intend for those to be there for 5 or more years. And so those are kind of that's the lifetime. So it's pretty stable. We can spin up another one and then have a few years left on the previous one and rotate them around the city as we need to. For semi-stable nodes, we call it a hub, and it's usually a tall condo or a co-op building or a hotel or a city hall type building, something that's tall, and it's kind of a neighborhood staple, and it can last from 1 to 5 years. It could be longer, it's not a problem, but it's just a node that aggregates the local neighborhood and helps send it over to a super node. And then there's just random buildings, which we just call nodes. It could be a 3-floor building or a 6-floor building with apartments in it, and sometimes they last a week, sometimes they last for years. And so this is where people actually connect to the nodes or to the network, and they really use it from that point. So the goal is connect as many super nodes and hubs together, create this kind of hybrid topology with this really good point-to-point network overhead, and then have a valley with a neighborhood of many smaller nodes within it. And so connect all the nodes to one or more hubs or to each other. And in terms of design, that's basically what we've done. So if you look at our concept on the right from 2018, we kind of just did a real quick layout and said, what are the general neighborhoods in New York? How would we chop it up? Where would you put a hub if you had to? And then, what would they look like if we just connected them together in the most logical fashion? And we did this drawing on the right. And in the center here, you can see that as of a couple days ago, we actually do look like that more or less. And I turned off all the nodes. The blue ones here are just the hubs themselves. And so there's 1 or 2 in every neighborhood, and it provides good access into the neighborhood for nodes that are on shorter buildings. Our hub nodes are generally 10 floors or so. And then there's sector coverage and omnidirectional coverage for the neighborhoods below. And then once you zoom into the neighborhood a little bit more, you'll see that inside the neighborhood, you route rooftop to rooftop as much as you can. And then you go into a node that has an antenna that points to a hub, and you jump from hub to hub until you hit a super node. So the goal is 1 or 2 hops in the neighborhood, and then 1 or 2 hops in the hubs, and then everything else on fiber. So if you are in one of these red dots over here, if you trace to 1, 1, and 1, 1, you'll go to the first hop, 2874 is this blue dot, and then you'll hit 1340, which is way down the street. It's a hub, and then you'll hit another hub, and then you see this 1070, 89 addresses. These are all, you can tell, /30 point-to-points within the data center. So we jump through a couple hub nodes, or 1 rooftop node, 2 hub nodes, and then all data center to the internet. So the design is working at the moment. In terms of hardware, we use, as I mentioned earlier, pretty much everything. We use Cisco Nexus switches. We use 60 gigahertz point-to-point antennas, high power, 5 gigahertz antennas. We use 24 gigahertz antennas, and outdoor switches. We use kind of everything. And the nice part about that is it's really open based on the design of based on our routing design being brand agnostic. So we can use open, closed, free, cheap, expensive. Some of it we buy new, some of it we find somewhere. As an example of one antenna that really has worked out for us quite well is the OmniTick 5AC. I'll just mention also that one of the ways we handle all this diaspora of hardware is we follow a pattern of how to set up some nodes or how to set up hardware. And we use scripting to automatically generate the configs. So when you're about to configure a node, you generate the script, you generate the configuration, you copy it to the antenna, and you flash it. And so by having a set of configurations that are good, standard, and they're parameterized, we can easily deploy any different kind of gear without having to worry that it's not the same brand. You know, as I was mentioning, one good antenna is the OmniTick 5AC, which I'll talk about right here for a moment, just as a sample of what it kind of looks like in our neighborhood, in our network. So it's a router of 5 ports. So you can either connect 5 antennas or 4 antennas in one apartment, or 5 apartments if you want to. And so it's kind of a nice general purpose antenna for most buildings. So it has a medium range of 3 to 5 blocks with a toroidal antenna pattern on an omnidirectional antenna, and it can handle a couple hundred megabits of traffic. It's $120. So this kind of antenna is one of the staples of our network. And so we'll build installations like this out of it. You'll put an omnidirectional antenna on the far right here and a point-to-point 5 gigahertz antenna. Or you'll have a small hub where we have an omnidirectional antenna, a few sector antennas, and a couple point-to-points. So this is you know, something that we can easily deploy. Or you can have a point-to-point antenna and an open hardware with a Linux on it, and you can run OSPF on there as well, or any of the other protocols. So installations like this are typical for us, and we even get into bigger installations like on the left here, you can see we're using 60 gigahertz, 24 gigahertz, and 5 gigahertz, and we have somebody as a member in our group who has learned to use the proper harnesses. He's gone to the safety training. He drilled the concrete, put up the pole, and it's all done in a proper, safe manner with permission from the building. So, you know, we can do bigger installations or split the antennas over a couple areas. And so the hubs are typically looking like this or a little bit larger. And getting into the supernodes, we have 2 supernodes right now. You know, given this group as NYNOG, network operators, you know these 2 buildings. We're in 375 Pearl Street and 882 3rd Avenue. You know, we're on the rooftop of both of them. We have fiber and rack space in both of them. We operate a BGP ASN, 395.853. And each of these buildings has between 5 and 7 antennas. And, you know, fiber and power go to the rooftop. And, you know, we have a series of routers downstairs, for example, here. You know, so we look like a typical small carrier that has a handful of gear and some cross connects and some ports and so on. Nothing too special. But we definitely want to say thank you to our transit donors. This is not the last slide, but thank you for our transit donors, you know, Packet, Pilot, WebAir, Net7, and DKIX. You know, it might look like small, but we've hit 1.2 gigabits per second just a couple days ago. It's always, every day is higher than the last day, except if it's a weekend or a holiday. So our traffic is going up and up all the time. And you can see for fun, this graph on the bottom, this is not all of our traffic, it's just one link. On one of our links, we see that in the middle of March, our traffic kind of doubled, you know? And so they doubled because of coronavirus, people working from home, more people spending more time at home during the middle of the day rather than just in the evening. So we definitely have need, and you know, people are finding it interesting and important to have this system. So we're kind of proud of our 1.5 gigabits a second. A little bit more logical, our supernodes at the moment look a bit like this. We have 2, and you can see that an odd thing about them is there's no wires between them. We have some carriers at one side and some carriers on another side. And if you're familiar with running a BGP ASN, you'll know that you need to have these 2 connected. It's a bit of a problem. And so by running one ASN, we have to split our prefixes between 2 supernodes in order to maintain exiting traffic successfully. and we can't communicate between those nodes except without going through the mesh itself. And so there's a bit of a lack of redundancy here. And we have a few more connections sitting on the table that we can't actually accept because we don't have enough cross connects at the right spot to be able to plug it in. Our goal is to look something like this with a more core and leaf or spine and leaf design, where we have a few pops that are in major buildings, 60 Hudson or 111 8th Avenue or something else. And then we can aggregate all of our traffics there that's destined for the internet. And then we can run fiber, we can accept fiber to different areas, to some of the hubs. Those 50 hubs, we don't want to run fiber to all of them, but if we can run fiber to a couple of them, we can really jump all the way over to a neighborhood with an express route rather than having to jump hub to hub. And we see this as a bit more of a way to be a little more scalable in terms of getting traffic out to the neighborhoods without bottlenecking through a small number of antennas. So if you're flush with space and fiber and you have it sitting there and you don't know what to do with it, here's a project you could do with it, right? We're interested in making that happen. And so almost towards the end, how can you get involved? Well, you can ask questions, of course. We're an open book. We're not in competition with anybody. We're just this necessary alternate that's on the side for people who can't get internet a different way, and so they go through us, or they want things that can't be done on a traditional network. So you can ask questions, talk about it, suggest things to do. You can read our docs. We think they're pretty decent, and a lot of other groups are helping us improve them and using them to build their own networks. We have Slack, so join our Slack. You can join our network, and you can look at our volunteer page to see what kind of things we're open to doing and what's going on. But just be open to work in a non-conventional way, because we're not doing things the way that we're not doing it the proper way always. We're doing it the way that works the best for what we're trying to accomplish. Right? And so there's something for everybody. I'll make a plug if you feel like donating. I mentioned everything we have is basically from donation. If you have a couple, we don't need just cash. Cash always works, but if you have space or meet me room access and you would like to help us run a pop, that would be a really great thing. Or if you can advise where we go next. I know a few of you have reached out to me in the last few months, and we've been a bit busy, but it's something we're always continuously interested in, and it would be great to have more interest in that. Or if you have a rooftop with commercial antennas, we could take 2 square feet next to you or 1 square foot next to you. It's not a big deal for us. We're not a big deal at all in terms of power or signal. Or maybe there's some spare fiber strands in the ground that you're not going to use for the next couple of years. You can loan it to us, or old routing equipment. Transit always helps, and peering as well. So that's a shameless plug for we're this local thing that we're trying to do a good thing, and we're open to whatever. We're very flexible. So, thank you very much for listening to this presentation. Yes, and this is an image of Manhattan over 375 Pearl Street on a cold day. So there we are. Thank you very much.